Okay, this question is 287. Find the duplicate number. It's a LeetCode medium. And we're given an array of integers nums containing n plus 1 integers where each integer is in the range 1 to n inclusive. So this means that the array is going to be 1 longer than n, and then we're going to have 1 through n as the numbers in the array. So there's no number 0 in the array, so we know that there's going to be at least one duplicate number. And then they tell us, yeah, there is only one repeated number in nums, and return this repeated number. You must solve the problem without modifying the array nums and uses only constant extra space. So we can't use our hash map to see if we've already seen a value and just move through the array that way and check for duplicates that way, because that adds extra space. And we also can't do something like sort the array and then check like 2 pointers here and here and just increment those both to see if there's any number that's like, any two of the same number next to themselves, because that would be O of n log n for the sort instead of linear. So this is kind of tricky because one of the solution that I'm going to use is using Floyd's algorithm, which, because of how this array is set up, we can treat it like a linked list. Like the node is a pointer to the other indices. So for instance, 1 would point to this index, right? And then this value could be a pointer to this index because that's 0, 1, 2, 3, right? And then this 2 would point to 0, 1, 2 to this 4, and then the 4 would point to the 2. And then that's where we would have something called a cycle, because the 2 would point to the 4, 4 would point to the 2. So in a linked list, this is a cycle. And then Floyd's algorithm is used for cycle detection. So you can look up Floyd's algorithm on Wikipedia. I'm not going to go over it, but I'll show you how to do the algorithm. First, what we do, we would have a fast and a slow pointer. And then what we want to do is look for the first intersection. And this occurs when the numbers are the same, or the values are the same. Or actually it would be the elements are the same. The elements in the array are the same. Okay. In a linked list, it would be the nodes being the same. And then, so first intersection, elements are the same. And then what we do is we forget about the fast pointer. And we keep the slow pointer, but we make a new slow pointer. And then we just increment both the new slow we're gonna loop or increment until another intersection. And this will be the entrance to the cycle, which is the repeated number we need to return. Okay, so make a fast and slow pointer. We start them at 0. And then we detect for the first intersection. which will have a while true, because they are technically intersecting currently. We need to loop until they intersect again. Well, we don't count these instantiated indexes as the first intersection, indices as the first intersection. We want to look for the first intersection after this point. So we have to say while true, and then we have to break when they intersect. And then we increment like this. Num's fast. And then it's like this. We go like that. And then slow is nums like that equals num slow. Okay, and then there will be an intersection. We break here. And this has been rewriting fast and slow. So right here they are intersected. We create a new slow pointer. Set that to 0. And then we don't have to worry about the initial intersection anymore, because this is not the old slow pointer is not at 0. But let's see. So we say while slow is not equal to new slow. We're gonna go and increment slow. And then new slow. Ooh, I do that. Like so. And then after that, we just need to return. This is the second intersection, and we return slow. So we'll run this locally. These are all the test cases that they have as examples in the question. Let's just go over it. So, okay, we increment that. We find the first intersection. We break once they're intersecting. Make a new slow pointer. And then we increment the slow and the new slow one at a time until they're both equal and these two intersect. Then we can return slow, because that's how we detect the entrance of the cycle. Oh, I have to save it. Okay, so 2, 3, 1, 1. Let's go ahead and plug this in. Let's run the code. And let's submit this. Okay, there we go. Yeah, this one's kind of tricky because the way to beat these constraints is to pretty much memorize. One of the ways is to memorize that algorithm, and that's the way I'm going to do it. There are other ways of solving this, but this is how I'm going to prepare for this. All right, thank you.